Hi, everybody. My name is Caitlin. I direct research at the Longevity Escape Velocity Foundation. You've heard the name Aubrey de Grey mentioned several times this morning, and so we are the third nonprofit research organization that he has led. Of course, as implied in our name, our mission is to accelerate the path to and hopefully reach longevity escape velocity. And so we primarily do that with our own research studies. We have a Robust Mouse Rejuvenation program where we are trying to double the remaining lifespan in mice, which on its surface doesn't sound super interesting, but if we have a chance, I'll get into a little bit more. But we have been working with VitaDAO these last months because we're effectively a science team of two trying to run what might be classified as an institutional scale research pipeline, which is very, very challenging. And there's a wealth of resources available to us to help accelerate our progress. We internally don't have the skills to do them. And so VitaDAO saw an opportunity, hey, we can help fundraise and get this work done. But in the process, let's leverage the expertise that is like latent in Aubrey's brain. Let's leverage that, make it accessible to the community, develop a tool that can be used not only by you guys, but by others as well to help accelerate the entire path forward, and not just this one research project. So that's kind of how we came to be sitting here.
Sorry, can I just intervene here? Just one thing about RMR2.
Yep.
So I actually heard Brian Kennedy recently on the Peter Attia podcast, and people passing it around. Brian was commenting that we needed a rethink through, some of these fundamental, these foundational research principles that are sort of underpinning longevity, which it seems to be the whole objective of RMR2. But could you just sort of describe that current sort of like state of understanding or paradigm?
Yeah, so what Aubrey is known for in the field is kind of this engineering framework, this way of conceptualizing aging as various kinds of damage that can be repaired if you allow yourself to sidestep your ignorance and treat it like an engineering challenge. And so instead of thinking about the specific mechanisms of, okay, this is how this gene interacts with this protein and it causes disease, we look at categories of damage which cause progressive failure. And we know that aging is, of course, this complex interplay of multiple systems interacting and progressively failing over time. And so it's kind of by definition going to require intervening at multiple damage points. Sebastian and others have mentioned today that, say curing all cancer raises life expectancy by something like 3 years on a population level. And that's because there are multiple other kinds of damage that are accumulating in parallel. And the next one is not being stopped by curing cancer. So something else is going to kill you in short order. And so our approach to trying to treat aging right now is to kind of see how much that threshold or how much the damage burden needs to be reduced by addressing multiple different systems simultaneously in order to get a much more robust effect size. Because thus far, the monotherapy approach that pharma uses, one drug, one target, one disease, it's really only brought us incremental change. And that's not enough for us. And I don't think it's enough for anybody if we want to reach longevity escape velocity. So, yeah.
Amazing. Alex, how are we tackling the problem of incremental change? And just share a little bit about yourself.
Yeah, absolutely. So thank you everyone for being here. I'm Alex, part of the core team at VitaDAO. So for those of you who were not familiar with VitaDAO, we're a longevity collective that was founded in 2021 with one single goal in mind, which is to eradicate aging. So we've been funding and developing a bunch of academic projects related to longevity since then. We deployed over $4.5 million into many academic projects. We were backed by Pfizer, as Paul mentioned earlier, alongside other crypto investors. And talking a little bit about Aubrey and the motivation behind it. So we had two goals in mind when deciding to launch the AI agent. One was to lower the barriers of entry and enable permissionless science. So this goes in line with what Paul was talking about earlier today. We wanted essentially to bring PI level intelligence to the public and to other researchers that we have in our community. So for instance, we have a bunch of independent researchers that may not even be affiliated with academic institutions that want to pursue their projects, and they're now using Aubr to refine their hypotheses, to run ideas through them, and hopefully one day also use the agent to operationalize their experiments as well in wet labs. So this was the first goal, and I think we've gone quite a long way, and we made quite a lot of progress on that front. And the second one was really to support the work of Aubrey de Grey and Caitlin at the Longevity Escape Velocity Foundation. We've been huge fans of Aubrey. We really like his approach. And the launch of the agent was a way for us to crowdfund for his project, but also build a product that they can use inside their own labs. So during this fire chat, I think Caitlin's going to be talking a lot about how they're using Aubrey already internally. So this was really the second goal.
Thanks for that, Alex. Caitlin, question for you around, I think we heard about the larger, broad, foundational, generalized models before. Why is it important that you, we have an agent here that's really trained with the perspective of Aubrey and the way that he sort of sees the world?
So, Paul said something earlier that the agent is trained to be highly opinionated. I actually don't agree with that because I find the agent quite useful, and Aubrey and I argue about science things all the time, and I don't butt heads with the agent on this front. But it is particularly useful, especially when you're trying to conduct longer-term research studies. Having guardrails in place can actually be really challenging. There are lots of different interesting tangents that you could explore. There are lots of trendy assays that you might say, oh, well, I want to include this and measure this, and it's really not in line. It's not an efficient use of your money or your time because it's not actually bringing you further toward your explicit research goal. And so when we're able to program in these are the specific guardrails within which I'm working, then you can kind of get nudges one way or the other when you're starting to veer outside of that. Yeah, okay, this is interesting, it's technically sound, the experiments that you want to use are valid for what you're attempting to measure, but is this really what you need to be measuring given what you've told me about what the purpose of this experiment or this study is? And so it's extremely helpful to have those kinds of guardrails in place that you can also, turn on or off when you're changing the settings of the agent when you're interacting with it. The other thing people discuss a lot is with respect to literature. Now, Aubrey, the agent, has been trained on a very specific but very broad corpus of longevity and longevity adjacent literature. It is a multidisciplinary field. It's like an omnidisciplinary field. It touches nearly every aspect of medicine and physiology. And so looking at a really narrow scope of literature, the way that academia is currently siloed, most PIs, most career-long researchers really only have a very specific domain of expertise. Now, when we're trying to address something as complex as biology, you have to be able to reach pretty significantly outside of that. And so I think the challenge isn't that we need access to publications. We have access through PubMed and bioRxiv and all kinds of other platforms, but the challenge is synthesizing it, especially when that synthesis is across multiple domains. And so that's where having an agent at your disposal can be really useful. I would also say that what differentiates this from an LLM is LLMs are really good at giving you information that's known. So it's a shortcut very often for a Google search. I want to know, tell me everything that's known about, this pathway or this thing. And it'll spit back a bunch of information about things that are known to the extent that we can ever know anything in biology. What they're not good at is identifying gaps or blind spots or saying, hey, this is what's missing. And one of the things Aubrey and I talk about a lot is thinking about aging in the context of like a Rumsfeld matrix. So the mapping of the information space between information that's known and information that's not known, and whether or not we're aware of that. And we try to focus a lot on what we think of as unknown knowns. So that's information which is available. People have studied it and collected it, but we are not aware of it because it's outside of our immediate scope, and things that we don't know that we're not aware of. And so having some kind of agent at our disposal, which is really good at pointing those things out to us, that can be really invaluable and save potentially millions of dollars and costly mistakes when you're conducting $5-6 million studies. So
Alex, just a question for you. So biology just isn't text. It's the study of sort of like living tissue and certain types of interactions, et cetera. But what are the prospective like multimodal capabilities that we're looking here in relation to the agent, and like how can it interpret different types of data other than just text?
Yeah, it's a very good question. I think we built the agent to be a science machine, really. And what it can do mostly through the new mode that we launched, the deep research mode, it essentially can, given a prompt, for instance, a user or a scientist is trying to formulate a new compound or maybe combine two therapeutics that have already been tested out in humans, the agent can essentially scrape through the entire literature, or at least like the corpus that we trained it with, which is quite fast. It can go look for well, how many papers have like tested this out at what dosages, and have there been like any synergistic effects between these two compounds and so on. So that's like one super powerful thing that the agent can do. The other thing is you can actually upload like a huge CSV file with your research data, for instance, if your project have already started, and the agent can essentially interpret that. You don't even have to spend a lot of time, formatting it and so on. The agent can interpret that, run that against the literature corpus. You can cross-reference, and you can essentially try to suggest next steps, or like how you should continue to investigate your research. It also browses through clinical trials data sources, and it tries to assess like if there is any like safety guidelines that it should pursue and so on. So overall, given like a prompt and perhaps a data set from the scientist or from the community, it outputs like a complete report with how you should move forward, and if there is any grounding or background in the literature about what you're trying to do.
We just happen to be running up against time, but just one last thing I sort of wanted to sort of outline and get your comment about. I think it's super cool how like you have this broad community that just jams with the agent. They come up with hypotheses. People effectively comment on it, and you see this like almost like this degree of online collaboration. It seems like this very expanded research community. We'd just love to hear your little thoughts about like what you've witnessed so far, any validating stories, roadmap for where you think this is all effectively going to go with like automated on-chain science, and the relevant sort of like science, like the prospective scientific outcomes that we could hope to expect.
Yeah, absolutely. Happy to talk about that. Aubrey today is the worst it would ever be, because it's been trained on data that is already out there, but it's always improving on new data that is coming in. So what we want to do is we want to have Aubrey almost like installed in many different research projects, and we want to be further training its knowledge based on the research outputs. So based on the raw data that research produces, but also the reports, right? So as I mentioned earlier, VidaDAO is a collective funded and developing research science, and we've funded and developed many of these projects, like more than 30. So if we can have all of this data flowing back into Aubr to improve in its knowledge, I think that's how we can create this kind of like knowledge flywheel effect and turn the agent into a really good science machine.
Yeah, I guess as far as future directions, we talk here a lot about democratizing science and expanding access for people, capitalizing on untapped talent. Oftentimes it's people who are outside of a field or domain that can come up with some of the most interesting ideas. I think the challenge in science in general, like it's the job of a scientist not to really come up with ideas, but to ask the right questions, meaning that you have an idea and you come up with a way of testing it empirically that is sound and that gives you, likelihood of answering your research question. And so one of the challenges when you're talking about democratizing science, one is certainly access to facilities. So if you are an independent researcher, you don't have a place to do your work. And even if you have funding, going through all of the CRO agreements and everything, sometimes they won't even conduct your work for you because you're not institution affiliated. That's one problem. But I think the bigger problem is without specific bench experience, actual experimental design is quite challenging. And like I did bench work for, 5 years, and some years ago. And even within that, like my specific domain expertise is very small. And so for the scope of things we're trying to conduct, not having an in-depth understanding, having done those things yourself, it makes it very difficult. And having a framework that is able to say, okay, well, I understand what it is that you're trying to do. Based on what I know from all of these other things, these are things that you're currently missing. So if you're really trying to test X and Y, what you have here is valid, but you're not going to get complete information without including this other group. So helping people kind of refine their approach to answering the research question, I think, is a really essential step and a valuable use of this agent. I also look forward to hopefully using this for publication. I don't think that we'll get a chance to talk much about it, but there's a lot of stigma in the academic community to this day about the use of LLMs or any kind of AI assistance in conducting science, because it's as if it's cheating or you're somehow not a very good scientist because you're leaning on AI to do it for you. It's the same using an AI tool as it is with any other tool that you would use in the laboratory. It comes down to how you use it, and everybody's using these kinds of tools in academia to the extent that they're useful, but nobody wants to talk about it. And being that we are a nonprofit and independent of academia and pharma, and we can do whatever we want, I would really like to see us be able to really showcase how, if something really is truly a novel contribution, if there's something that the agent is coming up with, we test it, it's valid, that there's no reason why we shouldn't be able to cite this, even potentially as a co-author. Because just like with any other co-author, you always validate anything, like you're attesting to the content of that publication. So whether it's AI generated or whether it's human generated, like the validation step really doesn't make any difference. But I think that being one of the first people to hopefully be able to publish with Aubrey as a scientific co-author, that might help change people's attitudes about the way that we use and admit to using AI in science and make sure that people are using it in a productive way.